And welcome, guys. Looks like we've got Arash here. How's it going, Arash? I think we got a. You're muted there.
All good. Yep.
All right. And
We're in.
welcome, guys. Looks like we've got Arash here. How's it going, Arash? Oh, got a little bit of a delay. Thanks for joining us. Both of you guys are all the way over in the UK. Oh, looks like we might be having some technical difficulties on the slide deck front. I'm seeing somebody's email there, so maybe we'll go back to there we go. Excellent. All right, wouldn't be an event if there wasn't at least one technical difficulty. Probably won't be the last, but it's all good. Cool. Well, yeah, thanks again, guys, for joining me. I'm actually in the US, in Oregon, so quite a ways away. And I think that's, as everyone knows, that's still kind of the world we're living in here. But I mean, it's, as Nadav mentioned a few minutes ago, I think what we're excited about MakerBot is the flexibility of being able to do more in more dynamic places and environments. And we're definitely going to be talking a little bit about that in this session. So, hey, Paul, how's it going?
Yeah, all good. Thanks. Yeah, not bad.
Great. Thank you. So, Paul, I'm going to start with you. So you, as we saw in the video before, you ProDrive recently competed in the Dakar Rally with Team BRX. Yep. Can you tell us a little, just really quickly, what that experience was like? I know we've actually talked about it a little bit, but
yeah,
I'm sure the audience would love to know what it's like.
No, it was a pretty intense time. I mean, the event itself is like 2 weeks of unbelievable pressure, I suppose. But the program for us obviously started a long time before that on the design side, and I think pretty much by the time we got out testing in the desert, that's when the pressure really came, and where we had to make a lot of testing in a short period of time, really, with the COVID pandemic and everything. Our whole program got very compressed, and at one point it was even questions about whether it was even doable. But so we managed to have a program a test program out in the Middle East that was about something like 2 or 3 tests, which was enough to get the car to a decent level. But we had to make some pretty quick changes while we're out there, and then obviously onto the event itself. That's when things start getting really pressured. You're talking about doing up to 500 miles or 1,000 almost some days, from one place to another in the desert, all traveling as like 3,000 people or something on the event. So there's a lot of cars on the event, and motorbikes and trucks and all sorts of things, and you're moving around Saudi Arabia, setting up a kind of almost a bivouac sort of camp arrangement every night. And the cars leave at 6 a.m. or 5 a.m. They do their 800 500 miles across the desert, and then you catch them at the end of the day and sort of download the data from the cars, speak to the drivers to do the debriefs, and then set about working on the cars that night to get them ready for the next day. And then often the crews aren't getting to bed until midnight or later. And then the next morning, it's the same thing. Cars leave, you have to pack all your stuff up, put it in the trucks, drive another. So it's like that for 2.5 weeks, really. And it's quite a pressured environment, especially when you're competing against the best of the best for that sort of thing. So it's a tough job.
Crazy. Yeah. So, and obviously you guys were, one of the tools you were leveraging was the 3D printer, the Method X in your truck, and also in your shop as well, right?
Yeah, I mean, that was one of the big changes for us. I mean, we've used additive manufacturing for a while, I would say. We don't just operate the BRX from here. We do all the Aston Martin race cars, factory designed and built race cars are all done here as well for Aston Martin. So that's hundreds of cars, and we're using this technology all the time. But what was new to us with the method was actually being able to take the machine, something of that quality in that such a small package, meant that we could actually take the machine with us in the trucks out testing. That was one of the big sort of new things we've done, I would say, in this last 12 months, and operate literally in the middle of nowhere. So to the point where you cannot see trace of another human being. We have our tests set up with trucks and all the stuff parked out literally in the desert, with a generator running on the trucks. And we have 2 Method X's. I mean, in the end, they're so cheap nowadays. I mean, I think when we started doing this kind of thing in probably more than 10 years ago, the machines of a similar capability of this machine were more than 10 times the price or something. So they were a big decision. Nowadays, it's not much of a decision to decide to get one of these in your armory. And so we had 2, and we leave one in the workshop to produce parts for the cars that are in build. And then the other one is in the truck, in the test truck, and then in the event trucks, actually, so that we were able to print stuff in the middle of nowhere, based on the results of that day's testing. If we found something that sometimes if something literally failed because it wasn't strong enough or was subjected to environments that we weren't sort of fully prepared for, or quite a common thing is for the drivers to say, actually, I could do better in the car if something was slightly different, and then we're able to sit there straight after the debrief, knock a design up in the CAD in a couple of hours, set the print off overnight, have the parts. I mean, some of the parts on the car anyway build in less than an hour, so you can do those quite quickly. But some of the longer ones, leave them running overnight, get them fitted to the car for the next morning. So when the driver's from his perspective, he did the debrief saying, I would like to do this. And he goes back to his accommodation while the rest of us are stuck in the desert doing re-prepping the car and so on. Then he turns back up the next morning and it's all there on the car fitted. That kind of thing is a big step forward to what we do before, particularly when you've got limited testing. You can't say, well, we'll do that another time. We'll do that for another test. You're literally, we'll do that for tomorrow.
Right. And Arash, I've got, I'm going to ask you a similar question, but so you guys have, obviously you're a kind of a bespoke motor car, sports car, hypercar company that you've got there. As everybody saw in the video before, hopefully, what's your 3D printing setup? And I guess just give us a little download of what you guys are all about at Arash.
Yeah, I mean, listening to what Paul was saying, it's something that we'd like to start doing as well, if we do testing, but it's probably more suitable in the desert. As you can't tell, we've got Goodwood Festival Speed coming up. I was just messaging Paul, and when you're away from the workshop, it's pretty scary. You don't have the bits and pieces you need to just be fabricated. So I think the Method X is pushing that for us, not only what we do inside our workshops, but in testing as well. So I'm really interested in what Paul was saying just then as well, how it works out, and it makes a lot of sense. What we're doing over here is using parts for the cars themselves, so they aren't just for prototype work. We are actually using them inside our cars for 2 reasons. One, they're strong now, so these sort of parts that I'm holding, so it's a gear change part. It's strong and lightweight and heat resistance. Its temperature or heat deflection is quite high, whereas the filaments that we use for prototype for model making isn't strong, and it's not high enough for the pressure that we've been dealing with. I've just noticed someone said, can you make spoilers in 3D print? Yeah, you can. If you're using ABS plastic and some carbon fiber and you glue it together to make a bigger structure, yes, absolutely you can. And you can use parts for the spoiler as well, so the end bits and inserts. So yeah, absolutely, that has changed the game. As long as you're using ABS plastics and carbon fiber filament. So for us, using the Method X and using the carbon fiber parts it is a game changer. There are smaller parts, but we can construct bigger things. but we will be spending the next few months putting as many carbon 3D printed parts in our prototype and production cars. So it's a pretty exciting time.
Yeah, and you guys also, we talked a little bit about Paul's team with the Dakar Rally. You guys have some exciting news as of last week, right? Arash?
Oh, me? Oh, yeah.
Yeah.
Sorry, I thought
Speaking of current events.
Paul got something every week. Yeah, it's told me about a 3-year turnaround for everything. It's really exciting. Yes, we have a new hypercar. It's electric, all electric vehicle. Came out on Friday as our proposal of what we're doing, showing people how we're making it, giving the stats and data. And it's a big thing for us as a tiny outfit with so much resources. But yeah, to make something, it's a 2.4 megawatt system, which is really, really high power, with 20 kilo electric motors, 4 of them, and 2 lightweight carbon fiber metallic gearboxes, and this beautiful shape, endurance racing inspired shape. So I'm really delighted to release those images. You're seeing some of the engineering data there. You're seeing some of the chassis data, some of the parts, and someone mentioned, are we going to put parts on the rear wing? Yes. Actually, the rear wing that I'll be making myself in my prototype clean room will have parts made on the Method X that we will be bolting onto the mold to make the parts for prototype checking, rather than going to titaniums or aluminiums, just to see how it goes, because they're super light. They've got great properties in them, and we don't have to wait 2 days for the parts to arrive. We can just get them literally on the Method X and bang them into the mold and make the wing structure itself. So it's it's good that we've got this amazing hypercar out there for everybody to see what we're doing. And by a few months' time, you'll see it driving around. Pretty epic.
It looks epic. I definitely implore everyone to check it out.
Yeah.
So I'm gonna ask Paul, because we've both, I think both of you do something similar, which is kind of speaks to the type of companies you are, Motorsports and kind of low volume, bespoke kind of custom cars. And Arash, you do Motorsports as well. I think ProDrive's actually crossing over to some of the bespoke side, and you guys are doing a little bit of both. So, but it kind of brings in this idea, Paul, of prototyping versus end use parts. When do you, I mean, you guys both use the printers for both, right?
Yeah, I mean, I think most of what we use is production, to be honest. We do the odd bit of prototyping and sort of fit check and that kind of thing. I've got a piece here in front of me that's kind of, I'm not sure if you'll be able to see that, but that's just a printed version of a steel prop shaft component in the drivetrain that we wanted to assess a different. We had a serviceability problem. It was quite difficult to change one of the rear prop shaft on the car. So we came up with a new concept, and instead of making it in steel and that, it was possible just to print the parts on the Method X and build a kind of a dummy assembly and check the fit. It's the kind of thing that you theoretically can do in CAD, but often it takes longer to do that, to be honest, and probably with a lower level of confidence than doing it in real life. So we use it for prototyping, stuff like that. But I would say 95% of what we do is production parts. And yes, I mean, one of the sort of big things going on from the Dakar, I mean, we're still in the middle of doing a big update on the Dakar car for next year, because there's new rules for next year. So the car's all of a sudden is going to be an absolute monster compared to what it was this year. It's already a big monster, but it would be an absolute monster for next year. On top of that, we're also looking at, we've been asked by our chairman to basically produce a road variant of this, which is quite a challenge when you consider what kind of car it is. And the idea there is to do very customized, a small number of very customized cars for very particular customers, I guess, kind of high value car, as you can imagine. The idea is it's kind of the most extreme and crazy off-road car you could buy for that can have a road registration and so on. And in there, we're anticipating sitting, part of the process of defining the spec of each of those cars will be sitting with the customer and defining exactly what it is you want. And so everyone can form an orderly queue after this meeting if you want to order one. But the idea will be to offer a fully bespoke service there. And if someone wants something very specific, I would like to have a champagne cooler or something like that, then we will do it. And that's where I think, if you're talking about one-offs, you definitely don't want to be tooling too much if you don't have to. And we know that if we do the design the right way and we set the machine up in the right way, we can make some really, really good parts, really nice looking bits. And, so that's going to be an integral part of what we do.
Yeah, you just have to warn people not to open the champagne after they get off driving the dunes, because that could be a little messy in the car. Arash, how about you? So prototyping versus real parts. Love to also hear about like some of the materials, how you decide what materials to use for prototyping or end use parts.
If we can 3D print it and it fits on the bed, we'll use it. That's basically it. Until if we get bigger bits, then as we move to dashboard parts, I will be pretty difficult about it and try and 3D print it all and glue it together or lock it together like Lego, rather than going to a partner, because the number of partners that can do this sort of work is quite small in the UK. You could go to overseas for certain large components, but you try and avoid it. As Paul was saying, if we will try and use pretty much everything we print for going on a test vehicle or a production car. We've just done some parts for a customer, and everything on that component, it's a large wing actually we made for a customer. We're making about 100 of them. As well as doing the car company, we're doing some subcontract parts for people that just want to get stuff done. They don't know where to go. And there are 1, 2, 3, 4, 5, 6, 7, 8 3D printed components on that. The rest of it is carbon fiber structures, which are insanely expensive, labor intensive things to do. And if you wanted to go and start making other bits and pieces, they have to be cast or machined in a very strong material. And, an equivalency of something like this, but a little bit bigger, it could be as much as $1,000, and it takes a long time to make it. Whereas we just put in filament and you get this out of it, on your desk. So you do that 10 times, it's worth it. Some of the parts only take 4 hours to make. So where we probably give you a much more elegant answer by the end of the year, when more and more parts are made through the MakerBot Method X on the hypercar. But I would have thought lots of bracketry fixtures will be made fearlessly, as we said in the video, to get us going. But the more learning that we do on finishing, the better. So we try and avoid metallic structures to be done through a traditional machining process, because it is extremely slow, and they're heavy. They're still heavy, these bits, and treating these components with a chroming or a polishing process on a metal anodization on plastics or carbon filament parts is something we'll be playing around with, which means that we can make more intricate switches, more intricate champagne holders, as Paul was saying, not so much maybe for a hypercar, maybe a drinks holder or some fine structures around it. And there's a lot of effort today that I'm myself making to make parts that are not trying to hide being additive prints. It's kind of, look, you can see that part there, that's been 3D printed. Wow. there is a balance of he did it in his bedroom, or it's a bit like Gary, who did it, himself. To proper sports car companies made something that's really intricate. So that's that balance of trying to make stuff. You don't have to do too much finishing, but it's wow, that's new tech going on in there. And I've seen some of the big car companies are trying to do it as well, and it seems to be working out very well. It's almost like there's a machine bit, great, it's really good, it's shiny. Well, there's an additive manufacturing bit. Wow, that's really tech. So that's
for sure.
Similar mindsets.
That's an interesting point. I'd never really thought of it like that, but I'm sure, especially at a certain price point, it's like, is this, a high performance part versus is it, is high tech part. So I've heard Paul, you've kind of talked about replacing some metal parts or using additive instead of metal for some components inside the car. One for, I think, lightweighting, maybe ease of building, but also just like the look of it as well, right?
Yeah, I mean, there's plenty of times. I mean, obviously, when you're working in like really high volume, then moldings become that's just something you do. But for our kind of volumes, moldings just aren't going to happen. It's never be good value. So we typically have not being able to use too many plastics, where realistically plastics are probably the right material. We've been more likely to use a machined aluminium part, or occasionally even a machined plastic bits, but also fabrications, so welded sort of assemblies, welded aluminium things. If it's a structure of a certain size, but doesn't need to be particularly structural, but it needs to be quite big, like the fire extinguisher nozzle mount part, this kind of bit that it's kind of voluminous, but it doesn't really have a great deal of mechanical requirements. But we'd normally be making that out of fabrication, welded aluminium or something like that, which, to be honest with you, when you look at the finished part, even though the guys are artisans at the job of the welding, you look at the finished part, it still looks like it's come out of the sort of 1980s or something like that, 1990s competition car. And I think the good thing with the printing, particularly also with the some of the higher temp materials, it's interesting. He's basically using a lot of the same material we do, the carbon filled nylon, where the temperature is just that bit higher, and it really opens doors to using those kind of materials in environments in the car, like in the engine bays, in areas that are, you would normally push it a bit past sort of traditional additive manufacturing plastics. And you're just able to produce a bit that looks nicer, instead of you have it in 3 hours after you've finished designing, or at least the first off to have a look at it, and so on and so on. You don't really commit a great deal of cost to get that first one tried. If it's a welded part, you're going to have to probably make a little welding jig, and so on and so on, and it takes ages, and you won't get your first part in two weeks. You get it in 2 hours, and it's probably lighter, nicer, certainly nicer looking, and in the end cheaper, actually. So what's not to like about all of that? And so we're doing it a lot. The funny thing is, it's I think I might have mentioned this before, I can't remember, but we've got a couple of, all of our designers are in tune in their head. They're thinking additive manufacturing all the time. So and a couple of our guys have got their own machines. You talk about bedroom manufacturers. Well, we've got a couple of guys who literally do have their own bedroom machines and so on, and they are really into it. And so obviously, when they're designing, it's they're not thinking, right, how shall I machine this out of aluminium? They're thinking, how shall I make this on additive manufacturing? And it's amazing when you start off with that mindset, how many of the parts you have to release for the car can be done that way. It's we've got a lot on this car. On the updated car, we'll have even more. And obviously, like I say, when we come to this customized off-road road car, there'll be a heck of a lot of parts there.
That's great. Yeah, that actually makes me think. So, like, Arash, your companies, or you've had motor car companies for what, 20 plus years you've been in business, right? Oh, I think you're muted there.
Yeah, sorry. Yes, we've been around 21 years.
So sorry, I was just going to ask, in like 20 years and up till using additive more recently, what's that process been like of adopting additive and kind of the mindset that Paul's talking about of like thinking for additive and knowing that's a tool? Because I know that's actually a struggle for a lot of companies these days, because the technology is new. They're not necessarily used to it, and so they don't think of that first as like a tool or an option for manufacturing.
Yeah, the mindset is you've got there's three choices at the moment. You've got large structures for us, curves, large structures with fixed fittings behind it, body panels or chassis structures. You kind of diverted down the carbon fiber route for low volume up to like 500 units per year. Then obviously you go down to your pressings that you find in saloon cars and everything else. So we're kind of like, large structure has got to be a curvy carbon composite structure, which is insanely expensive. The machining, the molding, the making the part, the preparation, you get something out of it. Then the next level of thought is, can you make some for medium to small? You're machining blocks of aluminium or blocks of plastic, and then your mindset's like, I'd have to get that machine like an upright. So this thing here. So this is a part that you saw in the video. So that's an expensive part that's been bolted to an even more expensive part normally, which would be made out of a very strong, tough aluminium. If we could 3D print that, then we wouldn't have to do so much finishing afterwards, which is equally more expensive. And when you get it wrong, it's really painful, because that's like a multiple £1,000 part there. So once you start thinking, I don't have to do it through that traditional process, that's going to take a lot of time and it's a cost. You sort of, for us, every penny counts. And I'm sure for other companies, like there's big companies like ProDrive, they have to still be signing off on their purchase orders and whatever else, and the machinist time. And then it goes down to, well, I can machine something, or I can use an additive process. And that mindset's quite unusual, because you're no longer relying on the fact it's a 5-axis cut. You can make something organic, curves, shapes, intricate structures, fearlessly again, and at no cost other than the filament. So that the mindset is changing towards, well, what can I actually do with the tools I've got here? You've got a new material that's higher in temperature value, as in it will heat deflect and not melt at 65. So you can start putting it in carbon structures. And then also, it's what you are used to is now being pushed, and that is changing. So for the last year, we've been using PLAs, which is great for model parts like this lovely wheel that we did for our 1/5 scale wind tunnel model, dynamic test model. But it won't take too much temperature, or it won't take too much pressure. Even this is a tough filament we've used for this. But now we're going, hang on, you've got this carbon fiber filament, we can push the boundaries a lot. So a gear change part, this is under a lot of load all day long with a bearing in it. And, it's strong, and it's not going to melt as well. So the mindset's, well, I can do that bit and I can do that bit. I can make the pin now. That's great. And then for us going inside the internals of the car, we can start making things that for the air conditioning unit, the heater units, and it goes on. We can start making stuff that is durable for switches, stalks, door handle parts that we normally have to spend £25,000 on tooling just for a small structure in plastic. You don't have to do that anymore. You can do it in ABS or carbon, and that starts changing the mindset by a long way, because you become less stressed about what parts are going to be available in 2-3 years' time. Are they going to be manufacturable? Yes, they are, because it's on a printer now. That's a good quality print. Plus, our other concern is, as the welding of metals and machinists become more valuable as individuals, it takes a lot of training. You're not putting them under pressure for doing the wrong jobs, they're able to do the more valuable jobs. Does that make sense? So what Paul's doing with the welding of the tubes, we've been doing it over here. There's very, very skilled people for exhausts and chassis. But we've moved more towards the composite stuff, which is equally as insane skill set to do laminating carbon fibers and machining big parts. But it's reducing that worry factor that you can develop really cool stuff without having that concern that you can't do it with the right skilled people. You've got a different type of skill set now, which is becoming more universal.
Right. Yeah, you've probably seen that. I'm sure you guys have seen that those skill sets transition to more digital,
Yeah.
like students coming out of university and stuff like that with a kind of their more CAD mindset, or like CNC rather, I mean,
yeah, I think that the computer modeling to do surfacing, shapes, filling and cutting and drilling holes is getting better. The software companies like Dassault Systems, SolidWorks and CATIA is getting better. It's a lot more practical. You don't have to spend 3 years learning how to do it. It is getting better. It still takes a long time don't get me wrong, to learn how to do it. And once those new apprentices come in, the new generation come in, they get more comfortable with that. Then they can start using the additive stuff and go, wow, I just made a gearbox out of, filament. It's unusual to see that, the small gearbox or stuff that moves, or stuff that bends. And, you normally, 3 or 4 or 5 years ago, you couldn't do that. You'd have to go to a machine shop or give it to an expert machine shop or an expert prototype company. And those guys, they're pretty busy with other things. So it's a mindset change.
Speaking of, you were talking about high temp materials, nylon carbon fiber, and I want to bring this over to you, Paul, because I saw some questions come in about the environment of Dakar, and when you guys were testing out there, you were in the desert for a few months doing testing and trials and printing and putting parts on the car. So, how do those parts? What types of parts can you use? Print in the nylon carbon fiber, how do they hold up in that environment, and how do the printers work in that environment too? I think I saw that question.
I think if I take the printers first, so we have no trouble with the printer itself in that environment. I mean, the ambient was high at times. High, like I'm gonna struggle to put it in Fahrenheit now, but sort of close to 40 Celsius. So that must be well above, close to 90, is it? I don't know.
It's used to 100s maybe.
It's hot, that's for sure. We didn't have any trouble with the printer itself, but the biggest problem we actually had was the generator on the truck. We had some overheating problems with that. We had to do it's the first bit of development work we had to do was to get the generator on the truck to be able to handle the ambient environment. And once we sorted that, then we were okay to run the machine. But yeah, we never had any failures on the machine there. Obviously you choose your parts on the car, you choose your solutions for the environment. But I don't think that the ambient of, the difference between typical ambient of 20, 25 degrees and 40 degrees doesn't really move the needle too far on some of those material selections. We had some parts in the suspension area that were sort of in the rear wheel arch where it's quite hot in there because you have a lot of exhaust gases exhaust exit on the side of the car, and they kind of inevitably recirculate slightly under the car, and then you've got all the rear brakes, and the rear arches are less well ventilated than the front. So it's quite a warm environment there. And then we also have some bits literally in the engine bay area where the ambient temperature then is 90 degrees, 100 degrees or so on. But I don't think we had any particular trouble with the environment for the parts, if you know what I mean. But I guess that's part of testing as well, is just to see where you are. To be honest, you typically know that your engine bay temperatures are going to be around about this, but until you run the car in exactly that configuration with exactly those turbochargers, with that average vehicle speed, which is very slow. At times in the desert, the maximum speed of the car is over 100 miles an hour. And in fact, if it's not limited, it's over 130. But some of the sections through the dunes where it's very technical sections in the dunes, the average speed's literally down at 30, 40 miles an hour, which is actually the worst conditions because they're still using the engine full bore, but you haven't got the cooling air. So then all the sort of temperatures start to climb. But you don't really find that sort of thing out until you go testing. But we didn't have any particular troubles. I would say that was quite a nice thing. And it kind of makes us think to push a little bit more in that area. Do you know what I mean? We can, and it's something we've also done in the past. We haven't done it yet with the Method X stuff, but in the past, we have on some occasions printed the parts in the plastic and then had them like nickel plated. If we should have parts right on the brakes, right on the brake discs for cooling, so we've used nickel plated printed parts, and that's worked pretty well in the past. So it's something we might look at again. Luckily, this car doesn't really need that kind of attention on the braking side. It's something perhaps we do more likely on a circuit car. But I mean, I guess we're not just using that material. We're also investigating a couple of other materials. We've recently got been using some of the flexible material. It's not one of the MakerBot proprietary materials. I mean, mostly we use the MakerBot materials, but this is one of the sort of open source materials to make flexible parts. And we've also recently got hold of an extruder that allows us to do the printed stainless stuff. That's a very exciting thing for us. That's where we can really look into some new areas as well. We don't know what we can do with that quite yet, and we'll do a few tests first, a few trial pieces and so on, and see what that unlocks. But going back to the software stuff you were talking about earlier, if we've got time, I don't know. We use a lot of topology optimization stuff in the finite element analysis, the strength analysis of stuff. We don't use it for all the time, but sometimes we use topology optimization for some parts. And what that typically provides you, if anyone out there's used topology optimization stuff, is like OptiStruct and some of those other softwares, is you get given back a part that looks like it's an organic part. It looks like it's human bones or something out of a mangrove swamp or something. It doesn't look like a typical manufactured part. And then normally your big trial, the big job then is to turn that into something that can be machined. Whereas obviously when you can start to, it almost is perfectly matched to additive manufacturing, where you can genuinely make the shapes that you want, and then the topology optimization is giving you the shape that you need, assuming you've got your boundary conditions set up properly and all that kind of thing. But the two things fit together really well, so that's another area where I think you're going to see. I mean, they're already out there, aren't they? There's a lot of very organic looking printed parts that are obviously very efficient weight-wise, and that's another area that we need to do more in as well. So looking forward to that.
Awesome. Yeah, so we just have a few more minutes. I see one question that was asking about OEM manufacturing and the use of 3D printing. And I know in this session specifically, we've talked mostly about kind of prototyping, design, developing of the car, and maybe the testing, and then the end use parts. I think it's important to note that a lot of OEMs and larger manufacturers use 3D printing and additive in assembly plants and factories and stuff like that. I'd say it's actually more common for tooling, jigs and fixtures, stuff like that, where manufacturing engineers are on the floor and kind of optimizing how an assembly line works or something like that. Creating gauges and fit checks and different kinds of fixtures. So just wanted to answer that question really quickly. And then I'm going to throw it back to you guys to wrap it up. So, kind of what's next for your companies and 3D printing, and what are you kind of looking forward to? We'll start with Arash.
Oh, you've seen we're quite electric focused now. We obviously have the petrol cars and the hybrid AF10. So I think we're moving towards more of the electrification process. There's a lot of discussions about structures for cooling around battery packs and areas. So that's a big deal for us. The heat deflection issue inside a battery pack is, big topic for conversation at the moment. So we'll be looking at different types of polymers to dissipate that heat nicely. We are very much focused on getting our first EV hypercar driving about. So you'll see a lot of Method X parts on there that we can use. And we'll probably be discussing that. And I think, what we want for the future will be this natural progression for MakerBot is going to be a taller or bigger bed, because we do most of the bigger stuff on the Z18 in different materials that we can get away with in terms of performance. And I think, we were excited to also see how the metal printing goes from what Paul was saying earlier on. The stainless steel printing on that is very interesting to see how that fares up with some of the carbon fiber parts, what we can use it for. So yeah, I'm sure we'll be doing many more of these, Sean. We've done a couple of these now, so it's almost like a live process over the year of what can we do, what have we got to work with, and how's it looking, and next year, who knows where we're going to be as a group of people around today, and our viewers watching you today. Where is it going to be? And it's going to just get bigger and faster and better in this world that we're in. And unless you're trying things out and testing things and seeing what you can get away with, you can't really tell until you just do it. And that's what we're doing. We're just doing it, and it seems to be working out okay.
I like that motto. Just do it. You should.
Great.
What about you, Paul? Yeah, exactly. What about you, Paul? Any closing words? What's anything?
Yeah, I'm a bit with Arash on that one. Is it actually you don't really quite know where you're going with this, because there's so many possibilities really that it's more like unlocking your thought processes and your inhibitions to try stuff. That's almost the number one thing. I mean, the technology is there. It's moving along all the time as well. Like I said, we're specifically sort of applications. We're looking to. We've done a lot over the years of sort of nylon-ish plastics, that kind of thing. We're on about pushing into the more flexible range to try and build some parts that are genuinely flexible as a usable part as well, not just flexible. AM's been around for quite a long while, I guess, but they've never really been greatly usable parts, and we want to try and push into the realms of being able to do some custom flexible parts, because again, flexible, if you try and make a small gaiter for a suspension joint or something like that, you're typically, before you know it, you're into massive tooling. And probably the first one you do isn't quite right, and then you're like, okay, right, now we need to retool and all this sort of thing. So typically we don't even bother. If we can get to the point where we're able to print some flexible bits that can tolerate the kind of abuse that would give it, then I think that will be a massive step for us, and that's something we're working on. And then going the other way is obviously into sort of ending up, if we're able to sort of get genuinely usable bits via the sort of stainless printing, that's going to be another interesting one, because again, that's just unlocks another area. Again, we can go to a bureau and get printed metal parts, that's nothing particularly new, but to actually have the machine on tap and be able to do something ourselves and get the parts sintered locally and so on, then it's just opening up new avenues all the time. And with this kind of customizable car coming, we also have a hybrid version of this car on the drawing board as well. There's a lot going on at the minute, and you just need the tools at your fingertips to do as much as you can, as quick as you can. And that's where we are.
Awesome. Well, I want to thank both of you for joining me today, this morning for me, this afternoon for you. Thank the whole audience. If you want to learn more about Arash, you can go to arashcars.com. Follow him on social media. A lot of cool content. Check out the new Imperium electric hypercar. And for Paul, you can check out prodrive.com, all the projects they're working on there. And if you are interested in checking out the MakerBot Method X Carbon Fiber Edition, you can go to makerbot.com/carbon. Check that out. And You can see the link in the chat here if you want to join us for the next session starting at 10:25 Eastern time. And the topic there is CAD design and robotics, an interactive lab. So be sure and check that out. It's on the Shaper 3D app on the iPad. Really cool new design tool. So yeah, stick around for the rest of the day, and we're just getting started. Thanks, guys.
Cheers. See you soon, Sean. Cheers, Paul.
All right, cheers.
And that is a wrap for our first session of the day. Please join us in a CAD design and robotics and interactive lab that will promptly start